Thank you. Good morning, everyone. Thanks for making it to the MD Expo and attending our class. We very much appreciate your attendance. These are great meetings to come to help learn and get to little gold nuggets of information. So we prepared for you a little kind of semi-educational class, product demo. I like it to be a real interactive class. My name's Julio Castro from Pronk Technologies. My normal day-to-day routine and job responsibilities are in sales and marketing, but I have a technical background, and we like to put together educational presentations to help biomedical engineers and clinical engineers with all the great work that you do. We appreciate everything you do. Not an easy job, difficult job in managing hundreds of different kinds of medical devices. So if you have questions along the way, please feel free to ask as we go through it, and we'll be happy to answer them and make sure that you have what you need to get information for doing defib maintenance. So we're going to cover a couple number of different things. We're going to cover the importance, of course, of servicing defibrillators, how to find incident information regarding these critical devices, reporting common issues reported to the FDA, and some things that we noticed when we did some searches for information, key points to consider when servicing these critical devices. And then we're going to do a quick demonstration on performing a preventative maintenance, some of the key steps. We won't go through the entire PM, and some things to look out for when we're doing the PM on defibrillators. So of course, these are critical life care saving devices. It's important that we pay really close attention to them. They're really high wear and tear devices, as you know, particularly if devices are used in the field, in field use. And so it's important that not only do we do the common things we do in testing these devices, but really pay attention to the wear and tear. And we'll give you some examples of some situations that have happened regarding that. And it's important to make sure we're following the procedures from the manufacturers. Defibrillators do have some unique testing requirements depending on the brand, so it's kind of important to understand maybe some of the differences from brand A to brand B. They're not always the same type of testing you have to do on these devices. And then it's important, of course, that we document this information. These devices come under a lot of scrutiny, so it's important we have our documentation very clear as to what we tested, what were the pass-fail results and such, so that we're clear that we've documented everything properly. And then, of course, we always want to make sure you're checking your event logs. Real common best practice to do on any kind of medical device. If there's event logs, particularly on defibrillator analyzer, you want to be looking at those event logs, looking for any common errors that could be causing a performance issue, maybe not today, but maybe in the future if you don't pay attention to it. So there's a database out there that's really available to all of us. It's a great database. It's an FDA database. It's called the MOD database is the acronym. It's a pretty common name. I don't know if any of you have used it before, but it's referred to as the Manufacturer and User Facility Device Experience. So of course, our government is great about creating acronyms. So it's a real important database that is available to us all. And it allows you to search for any FDA regulated device to find out any and all incidents, patient injuries that have taken place with these devices. So there's a link here at the bottom. If you want to copy the presentation, I'm happy to provide it for you. But it's a really good, useful database to reference if you want to kind of know, well, what's been happening with these kinds of devices in the field. And it's not particularly just defibs. It could be any FDA regulated device. So it's a good reference to utilize if you're maybe having some issues with some particular medical devices. You want to know, okay, are other sites around the country seeing a particular issue? So it allows you to search by product type, name, and you can look at any and all reported incidents to the FDA. So this is kind of an example of one. This is kind of an incident that was reported, and you can kind of see here, this is kind of the general screen. It kind of gives you an overview of information. And we took the manufacturer out just because we're not trying to point fingers at anyone. All medical devices will have issues that come up with them in the field. But I just want to give you an example of one here. You can see here, they kind of give you, would show you the model number of the device, but what was the problem in the field with that device, the self-test did not pass, it malfunctioned. And they're waiting for the manufacturer to receive the device to investigate it. So it kind of gives you a status of what that medical device incident is going through. And you can kind of see down below here, it gives you an event description. It shows you that during biomed testing, the device failed to self-test. Pretty basic, but an important thing to annotate. And in this situation, they decided to report it to the FDA. make it aware of it. Maybe it's an incident that's happened several times and they're like, well, we should bring awareness to it so that other sites maybe are seeing it. It could be something that needs further investigation. So you can kind of see here an example of that. And it's really helpful because the FDA uses this information, and honestly, the manufacturer uses it as well to kind of keep an eye in the field, what's happening quality-wise, incident-wise with the device. And as a manufacturer and as the FDA, they have to investigate any and all incidents. So it's a great resource to utilize if you're trying to kind of understand any particular issue that's been happening, or if you're considering buying a device, you kind of want to know what's been happening to it in the field, you can look into it there. So as part of the presentation, we kind of combed that database a little bit to look for common issues that are come up regarding defibrillators in general. So I looked over the last 2 years, common incidents that were reported to the FDA regarding defibs. And one of the most common ones was the display blanking. So technician or the user's trying to power it up and the display is blanking out. The device is powering off unexpectedly. So the user's trying to use it and it just turns off. Many incidents reported regarding that. Energy not being delivered on the defibrillator. So you're trying to defib the patient, maybe pace the patient, and it's not delivering the energy when it's supposed to. So a number of issues on that. You can see one common thing is that the unit was powering off, and you can see here even on battery power, trying to use the unit on battery power and it's not working. Lots of incidents reported about battery problems. Battery pins damaged. So of course batteries are a common thing that you have to check and replace on defibs, and it was interesting to me how many incidents were reported about the battery pins being damaged, which can of course cause an intermittent contact. So kind of brought the light on some defibrillator designs. They have a lot of contacts on their defib battery contacts, and there can be deformed in some way where the battery's not making good contact. So you all don't want to always assume it when you powers it up once that it's going to work. You want to inspect these things to make sure that there's no physical damage to them. The shock button working intermittently. Lots of incidents reported about the shock button not functioning properly. So these are just a sample of common issues reported to the FDA, and so it brings to light, importance of testing and really going through what we need to do to perform all of the things necessary to feel confident to put the device back into service. So of course, when we're testing these devices, we need a variety of types of test equipment. You need a defib pacer analyzer. If the device has a pacer option, an electrical safety analyzer, simulator, stopwatch, and of course, we need to make sure we have referenced the current service manual for the configuration of the defibrillator. And we need to be able to document all these results. There's some devices out there, some defibrillators, they have real specific test fixtures you want to use. They're specific to the device. The LIFEPAK's an example of one. They have a battery fixture they want you to use to do a battery compartment test. So there's some special test jigs that you have to either purchase or create on your own in order to do some of these tests. So they're not always the most straightforward things to check for. So of course, we've talked about it. Physical damage is the #1 thing you hear and see on defibrillator analyzers. Really needing to do a really good physical inspection for physical damage, not only with the hardware itself, the device itself, but you'd be amazed how many accessory, the therapy cable, the hands-free cable, damage to that cable, the connectors causing problems in use in the field. So definitely wanting to do a thorough test of all of your accessories, particularly the therapy cable, is really critical. Lots of incidents, as I mentioned, the battery compartment. It works once, but they would vibrate the unit a little bit and the battery would lose contact, the defibrillator would turn off, or the latches were damaged in some way, the battery wouldn't stay latched. So looking at that battery compartment is really, really critical for this as well. So when we're testing defibrillators, we need to do a variety of things. One of the most common tests and important tests is to do the discharge test, the shock tests. And so, of course, that shock test has to be able to function across a wide range of impedances across the patient, something that's referred to as a transthoracic impedance. And it varies from patient to patient. We all don't have the same impedance across our chest. And there's a number of things that can affect that impedance that the defibrillator needs to be able to compensate for. The age, the condition, body mass, weight, hair. And so the defibrillator has to be able to fire the right amount of energy under all these variables. So it needs to work properly. And so, of course, you're trying to defibrillate energy in joules, which is a function of time, voltage, and current. to deliver the specified amount of energy to that patient to hopefully recover that patient with the least amount of energy. There is a standard that's required for the defibrillator manufacturers to follow to adhere to make sure that the defibrillator can work properly within its specifications across all these wide range of patients. And there's an AAMI standard that they're required to meet during the manufacturing process. If you or your organization does actual repairs on a defibrillator where you're actually opening and repairing something, you really want to be following this standard for testing it to make sure it's compliant to the standard. And what it requires is it requires you to test the defibrillator across a wide range of impedances, trying to simulate the wide range of patients out there in their transthoracic impedance to make sure that it will fire within its spec across that wide range. And in some of the service manuals, you'll see there's charts in there that say, okay, if you're testing at impedance A, this is what your energy delivery should be. If you're delivering impedance B, your energy delivery should be within this tolerance. So there's charts in the table in the service manual that kind of lay out what the expected results should be across those wide impedance ranges. So it's important to kind of understand this as just a reference, because if you're investigating incidents, you're like, well, the nurse is saying they had to really energize the patient at a high energy. Well, maybe something's not functioning properly across a wide range of impedances. It may be good to test across those impedances. So of course, the manufacturer requires these tests to be performed, and they require it to be done at a specific impedance. So they don't usually, for the PM, you don't usually have to test it at a wide range of impedances, but those specify in the service manual tested at X impedance. So you want to make sure your defib analyzer is set to that impedance, because if it's not, if it's set differently, well, you're going to shift your results. You want to make sure that you've set it to the right impedance. The most common impedance, not 100%, but the most common impedance is set the defib analyzer to 50. So that's what you want to kind of confirm in the service manual. The defib analyzers in the marketplace have modules, have an extra accessory that allows you to simulate different transthoracic impedances. So there's usually a separate module you can connect to it, so you could vary the impedance on the test equipment, so you could check those other impedances. So it's something that definitely could be considered to need, particularly if you're investigating an incident. It could be a good test to do, to test it, to see does it work across those impedance ranges. So here's an example one of what the chart looks like across different impedances. You can see this chart here tells you for X setting of energy across different impedances. You can see the expected energy to be delivered varies. It's not the same. It should all be within specification, but they're not the same depending on what that impedance is. So the defib does a great job of being able to do that, but you have to be able to understand that the results could vary depending on what that impedance is. So you have transcutaneous pacing. Some defibrillators, particularly hospital grade, hospital level defibrillators, have external pacing, where you need to sometimes control the heart of the patient because it's not the heart rate's not being controlled very well on its own. And so using the same pads you would use for defibrillation, you can push DC current across the heart, so to speak, to capture the heartbeat and control the rate. And you do this by delivering current across those two pads, kind of positive and minus, to capture it. And so that current necessary to capture the heart can vary depending on the person again. So as a general rule, about 10 milliamps of current across here will usually be enough to capture the patient. But on some patients, you may need more current. And so that's where you see the need to test the defibrillator across different current and pulses per minute, because you want to verify, is it outputting it the right current, and so that if the nurse, the doctor, the EMT needs to deliver more current, that they're doing the least amount of current possible across the heart. Because of course, we used to manufacture a pacer in our last company, and the engineers would hook themselves up to be paced, and just watching them do it, it did not look very comfortable. So you want to make sure that you're testing this so that the least amount of current necessary can be applied to the patient. There are two modes, of course. You have demand pacing, or you have fixed pacing. So fixed pacing basically is, okay, I'm going to apply a certain amount of current, and I've set it on a defibrillator, and it's going to output it. It's going to output a certain pulses per minute, and it's going to capture the heart at X pulses per minute. And so that's fixed mode, which is the most common used mode for preventive maintenance. Then you have the demand mode, which is, okay, we're going to only assist in the pacing on the patient whenever they're outside particular ranges. So if the patient can regulate their heartbeat within plus or minus this, then let the patient's heart do the work on its own. But if it goes outside of these ranges, then on demand, pace that patient. But we're testing it really in fixed mode only. And this is what we do during the PMs. So for pacer testing, the same situation here, and it's easy to get tripped up on it, is that the manufacturer also specifies the impedance you're supposed to test pacing on. And it could be different, and not all manufacturers want you to test at the same exact impedance. So you have to make sure you've programmed your analyzer for that right impedance based on what that brand requires. And the manufacturer also wants you to test it at various pulses per minute. They don't want you to just test one test point. You want to make sure that at various ranges of current and pulses per minute, you're going to be able to have that pacer function work as it should. So that's kind of, general information on, one of the most critical tests on the defibrillator analyzer for delivery of energy for discharge and for pacing. The other thing that's very interesting, at least to me, but I'm kind of a tech geek, so maybe I'm a little over the top, is some of the requirements for doing some of the testing as reference to, in reference to electrical safety testing. So there are different safety standards that are required for you to follow depending on the defibrillator. So if you're following the manufacturer's specifications in their service manual, you got to do what they say in their service manual. Now, some organizations do across the board NFPA on all devices, which honestly makes it much more straightforward. But if you're going to follow the manufacturer standards, it's important to kind of understand a little bit some of these differences, and especially the pass-fail standard. So this is an example, and there's nothing wrong with this device. It's just the way they designed it, and they require their testing to be done a certain way. So this is an example of a LIFEPAK. So LIFEPAK 20E, I think they recently took it off the market, but there's still a lot out there. But what's interesting is they require the safety tests to be done according to two different standards. So it's not NFPA, and it's not just a single standard. They're doing kind of a combination of standards. They're using the 62353 standard for some tests, and for some other tests, they want you to use the 60601 standard. So it's important to understand this in the service manual because you have to kind of now make sure you're testing accordingly. And this is a little busy, but this is kind of an example of some of the tests. So they want you to do a couple of different tests. The earth resistance, of course, we know, ground resistance. You're doing an earth and what's called a direct applied parts leakage test. Applied parts, of course, anything that gets applied to the patient. In this case, they want you to do it with ECG. And they lay out their pass-fail limits. And what's interesting here is they want a ground resistance of 200 milliohms. So that's okay. They want the ground resistance to be very low, limit leakage as much as possible. And they want you to do an earth leakage test under these conditions, normal and reverse polarity. And so you can see the pass-fail limits are there at 2,250 microamps, which generally speaking, you think that's pretty darn high. But the way this device is designed, that's perfectly acceptable to have basically 2.2 milliamps of current as a leakage pass-fail limit. So if your organization follows NFPA standards, and NFPA standards allow a maximum of 500, well, you're never going to get this LIFEPAK to pass because it could have much more higher current leakage than that. And so that's where you have to kind of make sure you're referencing the service manual because they may have the device designed according to a different standard. And so you're doing earth leakage in normal and reverse in what they call normal conditions, meaning there's nothing, you're simulating nothing wrong with the power coming out of the wall. And then you're simulating a situation where the neutral is open on the device and measuring current leakage, leakage current. And you can see the limits even higher. They go up to 2,625 microamps. The leakage is acceptable. And then you're doing what's called a leakage ISO, or what's referred to as main and applied parts, where you're taking 120 volts AC and you're applying it to all of the leads on the device, and you're seeing what is the leakage current going to ground when you do that. And I'm sure you've done this test many times where you have this, the analyzer will indicate to you, look, the leads are hot, and it really is applying AC voltage onto the leads. It's current limited, so it won't be lethal. But if you're feeling drowsy, it'll really wake you up in the morning if you happen to touch those leads, for those of you who've done it. And so you have to make sure you follow this according to that standard. Now, what's interesting about this device is they want you to do another series of tests. They refer to it as a direct applied part leakage test, but for the therapy and SpO2 cable. So the therapy cable also is an applied part, connected to the patient with the pads. And SpO2 is considered an applied part because you're putting a sensor on the finger. So they want you to test that separately. Why? Because it has a different limit. You can see here for the lead leakage test for the ECG only, the lead leakage is maximum limit is 45 micrograms, which is pretty low, which is what you want. But if you're testing the therapy cable and the SpO2 cable, you're allowed up to 2,625 micrograms. That's considered a pass. So it's higher than what you would normally think, but it's perfectly acceptable on this device. So this is yet a unique test to this one particular brand. But they asked to have a third test that's a little bit unique, it's more common, I shouldn't say uncommon, it's more commonly being utilized in the US now, and service manuals you'll see it. It's a ISO 62353 standard. It requires a direct equipment leakage test, which NFPA doesn't do it, 60601 doesn't do it. This is an IAC 62353 standard. It says, I want you to do what's referred to as a kind of a complete leakage test, a direct equipment leakage test for everything connected to the device at once. So they want you to connect everything. Connect the ECG, connect the therapy cable, SpO2, connect your test lead to the chassis, and run a direct equipment leakage test. And the unique part about it is they have a very unique current limit. Under this condition, the current limit is 270 micrograms. So very different from NFPA and the other standards. Direct equipment leakage test, you're testing the leakage as a complete system and seeing what that pass-fail is. So I mention it because it's important always to look at that service manual and see what are the unique tests that are required. All defibs are not designed to be performed at the same exact standards. So the challenge, of course, for anyone doing any service on medical devices is knowing what to do, what is the procedure, what are the pass-fail requirements, how can I have the tools I need with me to be able to perform that service. So to kind of connect the dots, so to speak, Pronk has created an application we call Pronk Mobilize. And the concept is to be able to provide a tool for clinical engineers to take the test equipment that you need, whatever those happen to be for that particular device, add low energy Bluetooth technology to those devices so that you can control them from our app. And the app is designed to function as part of Apple iOS platform, I should say. It works on an Apple iOS platform. We're working on a Windows platform and an Android platform. And the platform is designed so that you can control these devices, get the information from it, and it will generate a report. But the unique thing, of course, for everyone as engineers is you may not standardize on one particular brand. You may have your preferred devices, or your hospital may have existing devices. So what we've done as well is we've designed it so that it's an open platform so that you can connect other brand test equipment to it as well. So currently we've added defib analyzers from other manufacturers like BC Group and a company called Daytrend, working on ESU. We've integrated TSI ventilator analyzer to the platform as well. So the concept is to give you a tool that you can tell the test equipment what are the tests I need to perform. They'll perform the test and bring back the results so that we can get captured as one entire report. And there's different ways you can utilize it. And to help kind of connect the other piece of it is being able to run the manufacturer level procedure that's required. And so we've created manufacturer level procedures for a wide range of test equipment to perform the tests. So we're talking about defibrillators right now, and the manufacturer wants you to run a particular series of tests. And so we've designed manufacturer level procedures. Now these procedures can be manufacturer level, or if you have an alternate procedure your organization prefers to use, procedures can be modified, tailored to how you prefer to do the test. As technicians, I'm sure you found ways to streamline the testing, maybe not in the same order or the same manner the manufacturer requires. So you're able to kind of tailor the procedures how they best fit. So the mobilized platform allows you to be able to connect your test equipment. In this case, you have the electrical safety analyzer, which we need to run. We need to do some simulation tests. We need to do defib analyzer tests. And I know it's a little tough to hear, tough to see. In this case, we're going to try to utilize the day trend defib analyzer to perform some of the critical tests. So the application allows you to connect these devices via Bluetooth to them and run the procedure. So in this one particular situation here, we have a library of procedures. And I can select the procedure that corresponds to this device that your organization created, or you're going to run the manufacturer level procedure. And we're going to follow it through step by step. So this requires you to do the procedure according to how you've designed it, or if you're going to follow manufacturer, how the manufacturer designed it. So the first thing I need to do is to be able to connect the devices, and I've paired them to it. And then I need to make sure I'm locating the right procedure for this device. So in this case, you can manually select a procedure, or if you're using barcodes on your assets, you can connect them to the procedure so that the technician can just scan the barcode and it will open up the procedure that corresponds to the device. So I know it's a little tough to see, but I could turn on the scan function, I could hold it up to the barcode, and then it will look in the library for the procedure and open up the procedure that corresponds to that asset ID. So you can create procedures based on the configuration of the device. You can make a generic one for all kinds of defibs. You control how you want the procedures to be designed. And then when you do that, you have the ability to customize the procedure on the fly, meaning that whatever flexibility you want to give the technician to execute that procedure, you can build it into it. In the case of the manufacturer level procedures we've created, you have only the flexibility to modify things the manufacturer says are optional tests. So an example of that is maybe you have Wi-Fi, you're using it on the defib. Okay, well, let's do that test. But if you're not, okay, I'm going to click on the options buttons here and turn off that test. And you could do this for other things as well. It's up to you to design the procedure the way you'd like. These manufacturer level ones are designed to, okay, if the manufacturer says you got to do it, we will not give you the option to not do the test, but these all could be modified. And then what you can also do is select the test equipment that you're utilizing. Am I using brand A, brand B, so that the automation knows how to communicate to that device, how to talk to that device and exchange information. Or if you have a device that does not have automation capabilities or communication capabilities, I should say, you can select a non-integrated device and just manually enter in the result. So it's about being able to have a procedure according to what your protocols require and run it. So I'm just going to give you a couple quick things here so we could walk through it. So we're going to do some defib testing with a day trend phase 3 defib analyzer. I've selected that. We'll just do a SPO2 test, a couple discharge tests, and some pacer tests. And then you hide the results. So the procedure is step-by-step procedure. So this methodology requires the technician to follow the procedure. So you're literally going to follow pass, fail here. If the device fails a test, you can log that failed test and repeat it, calibrate it, whatever you need to do. And then you just follow through the procedure. If there's a question about what do I need to exactly do on a particular test, like this is a power supply test. You want to check the power supply, make sure it's charging the battery correctly. Like, what exactly was involved in that? There's an informational window there. And from the service manual, it will give you extra guidance from the manual. Okay, you need to make sure you have test fixture A, part number X, Y, and Z. Make sure you're hook connected in a certain way. So it has all of the guidance from the manual so that you're not having to fish around, going and finding the manual to know how do I perform a given test. Or if you're on your 15th defibrillator that day, you probably already know what you need to do. And so it's kind of there as an option to look at if you need to. Now I'll let you kind of drive this a little bit. You can kind of see here that there's a pass fail. It highlights a test, and then it's just an informational test. You could hit pass or fail there. And I think the next one is an electrical safety test. So if you wouldn't mind, tell me what it wants me to do. It should tell you they're online. So here at the, yes, we want to connect the electrical safety analyzer to the defibrillator. So we've done that here. We've connected it. It wants you to connect your defibrillator to it. The Zoll X does not require a ground resistance test. The R's do, but the X does not require a ground resistance test. We need to do an applied parts leakage test on everything. So we need to connect our ECG leads, and we also need to connect our therapy cable to it as well. So the therapy cable is considered an applied part, so you need to connect that to your electrical safety analyzer, to the applied parts section here. So we'll go ahead and take this and connect it to any snap there. I appreciate Amanda helping me because she's much more technical than I am. And so we've got to configure the safety analyzer to do that test. And then you hit, there's a run button there, and it tells you run the test. So when you do that, hit run, it will execute whatever the manual says I have to test. It knows the pass-fail requirements for the electrical safety test, and it instructs it to go ahead and run the test. So the procedure is not just a text procedure, it's got programming in it that tells the equipment, do the test according to the requirements that either you've designed or following the manufacturer's requirements. So in this case, it's going to want to do a earth leakage test, requires that test, and it's going to have you do an applied parts leakage test, both ground and what's referred to as ISO. The mains on applied parts, 120 volts AC on the snaps. That's what it's doing there, and it's doing it according to the manufacturer. So what's helpful is it takes the guesswork out of what am I supposed to test, what's the pass-fail limit. And so it runs all of that test, and kind of in the background, it is capturing all of those results. And then it turns green, letting you know it's done. And so that's the general concept behind this, is you're going to have your guidance here, and it's going to communicate and pull the data back from the test equipment into the report. And you could do this with a wide range of devices. So I'm going to kind of go down here a little bit and hand it to someone else. And you can kind of see here that you have the next test that's highlighted down below. Okay. And it involves a defib analyzer now, right? So I want you to now do some tests involving the defib analyzer. So go ahead and kind of hit run on that. And this is a basic thing. This is capturing the serial number and the calibration date of the test equipment. So in this case, it's going to pull via Bluetooth. Okay, give me your cal date, because I want to add that time in a report. So not only is it doing the testing, but it's also capturing the calibration date of all your test equipment, and that'll be on each report. So you just tap on pass and then hit more, and then you can go down through the done, sorry, yeah, hit done, and it goes on to the next test. So you can see here. And then the next test, tell us what it does. Right, so go ahead and hit, so it'll be hit and run. And so it's going to now tell the defib analyzer, okay, we're going to do a leads off test. You can kind of see it here, that it's going to now have an ECG waveform displayed so that I could do the leads off test. So it told the defib analyzer, give me an ECG signal so I can pop one of the leads off. And we'll just take one of the hands-free leads off here and then make sure that the alarm occurs. So your guidance is there, communicating to the test equipment to go ahead and do that test. So that's the concept behind it, and then you're just pass failing and keeping going through it. So you can hit that and then done. And so that's the general idea behind it. And so the procedure requires the technician to follow the procedure all the way through. And you can see here, if there's a test involving a particular heart rate and such, you need to follow those tests. In this case, there's an alarm test you got to do, and you can kind of see there. It tells you what the test is. You can kind of see down below. What does it want us to do next? And then it's alarmed to what, 30, I think it is. It wants you to set the ECG to 30. Right now we're set for 120. So if you hit run, should be a run button on the right there. It should change the heart rate to 30. And I don't remember if we programmed the alarms or not. But the alarm would trigger, if I programmed them on, the alarm would trigger so you could verify that test according to the manufacturer. So it kind of allows you to have one user interface. You're kind of working from here, you set up your equipment, you're working from your procedure, and everything's kind of being controlled from one place. You don't have to interact with the individual pieces. So that's the concept behind that, so you can run all of your tests. So you hit pass and then done, and we can go on to some other tests there. So the idea is to give the technician something to be able to have a guide with them, because it's difficult enough to do all of the testing we need to do. And so this really can be a good guide for it. So of course, we got to do a next series of tests. And the next series of tests involve doing some discharge tests. So the Zoll Defib wants us to do a Zoll discharge test. What does it want us to run? So it wants us to do a shock test of 5 joules. So you're going to want to hit the run button there. It will tell the defib analyzer, go into, measurement mode for discharge. It's set for 5. And then we're going to go ahead and charge it. And then once it's set, fire it. And in that gray box down below, you'll be able to see the result from the analyzer for that discharge test. So what was the joule that it measured? 5.1. And what's our Pascal tolerance? Yeah. So it allows us to know what our pass-fail range is. You get your result right there. Hit pass, and done. Go on to the next test. So that's the general idea behind it, is to give you that guide, have you something there. So we'll do one more discharge test so you can kind of see it. We need to do another actually the manufacturer requires us to do a wide range of discharge tests. What's the next test it wants us to do? So we'll do 50 joules and then hit run. You hit run. You hit run, that will tell the analyzer to go and measure. Were you able to hit run? So there should be a run button on the right. Okay, so go ahead, we'll charge it again and we'll fire it. And if you have to repeat the test, you can repeat it and override the results. And then you should see a result come back. Yeah, and our pass-fail range is written on there as well, so you know what it is. Yeah, so you can hit pass and you can hit done there. So the benefit of having the mobilized procedures is your guidance is right there with your pass-fail. And so it really takes the guesswork at having to be able to do that. Now, what's interesting with the defibrillator analyzers is you have to also do some pacing tests. And so we'll skip that so you can see that. So what's interesting on the pacing test is you have to go ahead and set the analyzer up. So it wants you to make sure you set the analyzer properly for doing the pacing test. We talked earlier about setting it up for pacer. You don't need any defib. Cool. All right. So what does that step need me to do? I need to set the defib analyzer to 50 ohms. So hit run. You won't be able to hear it, but it remotely sets the defib analyzer into the right impedance to do the measurements. So now we can hit pass and go on to the next test. And for pacing tests on this particular device, I need to move the connections over to the pacing side, which is over here. So we can move the jacks, the leads over to that so we can do our pacing tests. Yeah, appreciate it. Thank you. And so what's the next test want us to do?
Set to 30 plus or minus 1.5.
30 milliamps of current for pacing and a pass 1.5. And what's the pulses per minute wants?
40 plus or minus 2.
So we need to set the pulses per minute to 40. So once we have it set up here, of course, we still need the technician to set it up. Go ahead and run it. And it's running, so go ahead and hit run. It's going to now put the defib analyzer into pace mode, and after it samples some pulses, you'll see some results come through as well. And it'll be a string of results, including pulses per minute and the current. So what kind of results did you get?
Current is 29.8. Width is 40.02, and rate is 39.9.
Yeah, good. So that's a pass. Of course, you hit pass and then you hit done. So it gives you complete guidance on how to do that. What's helpful is it tells you, it sets up the analyzer properly for that test, because that's half the battle, is what configuration should the analyzer be in, because we need to make sure we run that test. We'll do one more. We'll do the next test here. Everybody's turning for me, so. Anybody want to take a pass at it? All right, I'll do it. Oh, you'll do it? Sorry, I don't mean to put anybody on the spot. So if you read the little box there, it should tell you as a technician what you need to run. What do we need to do here?
Test rate at 180.
For the pacer pulses at 180. And how about our current?
Is going to be 140. 7 million.
7 or 7D? Oh, that's the tolerance. So we want to set the current to, and the current to 140, and the tolerance is plus or minus 7. So defib set for that pacer mode, we go ahead and hit run, and again, it'll sample it and give us the results. But what's helpful is that you got the setting on there, pass fail tolerance, and in that gray box below, you'll see your result. What result did we get?
Current is 140.5. And the width is 40.8 milliseconds. And the rate is 180.
Okay, so that's a pass, and you keep going. So done, and that's the next test. So that's the idea behind it. And I know these procedures seem maybe extensive, but this is what the manufacturer requires. It wants you to do all of these series of tests to be able to perform them and capture them. So you're able to do that automation for electrical safety, defibrillator analyzer, simulator tests. You need to do it. There's an SPO2 test we have to do. It will also communicate to the simulator and say, run this rate. It's going to run a saturation of 70%. It's going to tell the simulator set it to 70. Technician is going to verify the result here. So whatever automation is required, whatever testing is required, the app tells the user, run that test. The pass-fail tolerance is in there. For simulation, of course, you're going to look at the device, capture the result, and keep going. So that's the concept behind this Mobilize app, and this checklist application is allow you to have this guidance to run the tests. Now, some organizations want you to work from maybe your own device with your procedures. Maybe your organization has a centralized communication computer management system, a CMMS, and they want you to work from that. So not only can you run procedures, but the important thing is to be able to get the information into our CMMS. And so we have various methods to connect to your CMMS systems so that you can get this information in there. Number of different ways. One is you could kind of work like we're working here. We're kind of working offline of our CMMS. We're doing our procedures. We're capturing reports. And then we're going to import the data into our CMMS later. So it allows me to be able to work offline, and so that I can just get my PMs done later on, come back and import. Or there's other solutions where they want you to work directly from your CMMS system. I want you to work in your work order, do whatever our procedure says to do, and then have the information come back to the CMMS live. So that's another option as well. You can work live within your own CMMS, have your procedures in there, and then from your CMMS, it will wake up the test equipment, it'll do the test, and it will have the results come back live. I won't put anybody on the spot, but you can see the report at the end. The report at the end shows you everything that we would have done for that procedure. At the top is a header information of who the organization is. It lists every device we use to do the testing, what safety analyzer we use, the model, the serial number, the calibration date of it, the calibration date of the SPO2, the calibration date of the defibrillator. So anything you used, that calibration information is on the report, saves you the hassle of having to go find out those cal dates. If you ever have an auditor come in and they want to see your service history, the next thing they're going to ask you is, well, show me your calibration date on your devices. So it's all there on the report. If you scroll down, you'll be able to see all of your results, everything that we did, including all of the steps of the procedure we followed, the configuration of the procedure, and it allows you to have everything there. So the idea here is to have a complete report electronically. It eliminates the need to write anything down. No need to document anything. I know I've talked a lot. Any questions? Yeah.
So does that automatically go to any of your work order systems, or do you have to manually put whatever was in the app into the work order?
Yeah, no, ideally, we would work with your organization to create the integration directly to it so that we could have the data transferred into your work order, right? You could do it manually, but ideally we want to do an integration with you so that you can have the data be where you want it to be. We work with different companies. They want just the entire report to be in one field. We work with other organizations. They want the data to be separated into separate fields so they can mine the data looking for trends. Or if you want to have control of it completely, just control it from your CMS and direct the app as to where you want the results to be populated to. So we work with your organization and your CMS system to design it the way you prefer to use it. Or you could do the kind of the old school way, just attach a PDF. Just kind of depends on what you want in terms of the data. I'm sorry, someone else had a question? Yeah.
Two questions. One, hard to fix that entitled CO2, and you have a way of checking that. And the second question is, if you have an AEM on something and you're skipping one of the steps, you have a way to do that and mobilize?
Yeah, great question. So the procedures we designed are based on what the manufacturer requires. I didn't run the entitled CO2 tests in the interest of time, but the procedure does have that test. We don't have devices to do entitled, we don't manufacture devices to do entitled CO2, but the procedures do cover and explain step by step what that entitled CO2 test is. And in terms of AEMs, yeah, we're going to be releasing soon an application that allows you to create, edit procedures for organizations that say, I'm going to utilize our AEM procedure instead of the manufacturer procedure. And so if you'd like to do that, you'll create them. What's nice on the app is it distinguishes OEM level procedure from AEM. So the procedure will be labeled, okay, this is an AEM, so it's clear to you, clear to an auditor that the procedure you ran was either manufacturer level or an AEM. So these procedures, you customize however you'd like. You can AEM them all the way down or, or run the manufacturer's level procedure. And we created all these procedures, and as you probably know, creating procedures is very time consuming. And we tried our best to organize the tests in a workflow that makes more sense from a biomedical point of view. We actually hire biomedical engineers on our staff, and they look through the procedures, trying to combine steps, trying to organize it so that you're not having to connect, then reconnect later and do similar things. But if we're for the manufacturer level procedures, we really tried to follow the letter of what the procedure requires. So that's why they could seem long, but that's what the manufacturer calls out for. Any other questions? Yeah.
On the, you're using an iPad on that on the phone, is it harder to see or is it more kind of compressed out or?
It's compressed down, of course. So probably your good eyes can see it, but my good eyes see a little better on the iPad. Yeah. So you can see here the report. There's the serial number information of the medical device, and it lists out all of the tests we did. If you ran a checklist, it would list out all of the steps in the manufacturer level procedure or the AM procedure. So it eliminates documenting anything by hand. It's all electronic. You're just setting up the device and controlling everything from here, and the report gets generated. So it has all the information, the pass-fail results. You can add notes. You can actually take an image of the medical device. Let's say it's got physical damage. You want to add that to your report. You can actually turn on the camera function here, and you could take a picture of the device and then add that to the report, which can be handy if you're talking about a device that got damaged. You're like, oh, I want to document this. You know, let the individual know, let the staff know, or just document the fact that this device had a problem. I've actually had some customers utilize it to kind of confirm the results. They actually maybe don't want to document everything, or they want backup information. So they'll take a screenshot of some tests and have that as part of the report as well. So you could do a wide range of things with the report in terms of taking images, and you could add notes, of course. You have a wide range of ways you can move the data. It's up to you. Very basic ways, as we talked: PDF, print, email, cloud drive, and then ideally, if your organization has a CMS with integration capabilities, then we would tailor the integration based on how you would like it to work. And so we do pride ourselves in creating an interface. It's not just a standard interface, but one that fits what you'd like. And it's amazing. You go to different organizations around the country, and not everyone wants information in the same way. So we find that it's just a little bit better, even though it's a little more complicated, is to design it based on what you'd like. The app itself stores 1,000 records, so you have the ability to kind of work offline for an extended period of time and then upload later. So you don't have to necessarily have a live connection. I know sometimes you could be in a location where there's no connection to your CMS. So in those situations, you could just work offline and then upload later as well. So we also got a lot of input from engineers saying, hey, look, it'd be nice if you could help me out also with printing a PM sticker, because a lot of folks have to print out a PM sticker and they're manually filling it out. So we've worked with a company called Brother, probably common printer you've seen out there, laminated printer, and we've worked with them to design a PM sticker interface to our app. So Brother is a cool company. They make a wide range of printers. This is kind of their basic printer. It's $100, but we've interfaced 3 different Bluetooth printers they have. And what's cool about the Brother printers is they come with laminated labels, so and adhesive on it. So on the app, you can create the label the way you want, whatever fields you want to enable. You can connect this to the app so that it will print out a PM sticker based on how you want it to be configured. And so you could enter in title, facility, technician, asset ID, put the next inspection date. You design it however you want. The app will show you a preview of the label and then we'll print it. So it can be really helpful because not everyone has the same information they want on their PM stickers, and eliminates the need to be able to have to fill them out manually. What's nice is if you're using the procedures, if the device were to fail, let's say you did the test and it failed, it will not allow you to print a pass PM sticker. It will only allow you to print a fail sticker. So it's just a convenience thing so that we make sure we document our assets properly. If a device failed, you can actually print a custom label saying, say, do not use, needs repair. You design whatever the fail message is, and it'll print out a label according to what that message is. And a lot of organizations like the fact that it's multiple colors. So a lot of people use it like their cars. You know, you put different colors on different years so that you more easily identify when the next PM is due. So Brother has 6 different color labels, and you could just pick the color for each year. So it's, you know, for you as you haven't seen it, you know, it's a real simple cartridge kind of system. This battery runs for 10 hours on a single charge, so it'll get you through the whole day of printing labels. And each label, each cartridge, depending on how long you make the label, will print out about 100 to 150 labels. So if you're having to fill out labels manually, and then you're having to put tape over the label to kind of protect it, well, this kind of saves you all that hassle. Any other questions? Yes.
So where can you put the template for the sticker? Is it in the Mobilize app or is it in the Brothers interface?
It's within the Mobilize app. So there's a setup menu, and then there's a thing called PM sticker setup. And in there is where you can kind of design and configure what information you want on the label. Yeah. And if you wanted to, you can batch print too. Some people like to batch print ahead of time. Or if you only want to print based on the result of the device, you could do it that way as well. So you kind of lay out the information on the app itself as to what you want printed. Great. Sorry, Ramon, you had a question?
Yeah,